Large language models can now execute complex code and reason through multi-step logic within their local environments. But ask them to analyze a live trend or read unverified documentation from the open web, and they hit a wall. They are functionally blind to real-time internet data. Developers typically bridge this gap by connecting the AI to official developer APIs. Over the last few years, platforms like Twitter and Reddit have restricted anonymous endpoints, erected pay-per-use barriers, and demanded developers manage rotating keys. Relying on these official channels for even moderate access can cost over $200 monthly, effectively locking small teams out of running autonomous intelligence workflows. An open-source project named Reach approaches this problem differently. Instead of functioning as a centralized enterprise scraper, it operates as a decentralized capability layer. By bypassing the commercial API toll booth, it grants local AI agents direct, zero-cost access to 15 major web platforms, including GitHub, YouTube, and Bilibili. Achieving this requires routing the agent directly through local browser sessions and system utilities, rather than relying on external cloud endpoints. While circumventing commercial APIs successfully unlocks real-time capabilities, this architecture shifts the total burden of cybersecurity and legal compliance directly onto the local operator. Reach avoids heavy proprietary scraping software by delegating software installation entirely via natural language. It replaces traditional graphical interfaces with a specific architecture file called scale.md. The AI reads the YAML directives within this file as a structured routing table. These directives tie English trigger phrases directly to command line syntax, allowing the agent to pull down lightweight extraction utilities like YTDLP for video and GinaReader for web parsing. When a user types a simple instruction like search GitHub, the agent consults this capability manifesto, formulates the precise command line syntax, and silently executes the query. This setup lets the AI manage its own toolkit, eliminating the need for the user to manually memorize command line arguments. Beneath this process, a diagnostic command reveals a built-in failover system, actively probing endpoints during execution. If a primary backend is blocked by a platform, the router instantly elevates a secondary extraction utility to complete the task. Allowing the AI to manage its own capability layer transfers execution from manual human clicks over to machine autonomy. The operational challenge scales when targeting heavily gated social platforms that deploy strict geographic IP blocks to prevent server scraping. The agent bypasses the restricted API entirely by routing its requests through an active local Google Chrome session. This relies on session piggybacking. The tool avoids automated login flows by relying on the trust relationship the user has already established with the platform. By utilizing a standardized toolkit, it extracts the session cookie to impersonate human web traffic locally. This outgoing request secures continuous platform access, where centralized enterprise APIs frequently fail, and pipes the structured real-time research directly back into the chat interface. Deploying this architecture in a headless server environment changes the workflow, as active browsers aren't present. In headless setups, you must manually export your session cookies and inject them into a specific local configuration file. To prevent mass credential harvesting from this file, the system requires locking the file permissions strictly to the owner. While accessing public web data is generally legal in an anonymous state, utilizing a logged-in session cookie to automate data extraction explicitly violates the anti-automation clauses in nearly all platform terms of service. Doing so exposes operators to persistent account termination and potential civil litigation. Before the agent is granted active web access, a strict initialization phase is required. Setup begins by providing the initial GitHub URL and strictly appending a -safe parameter to the command. This flag instructs the agent to perform a dry run, ensuring no host OS system packages are altered during the configuration. The agent autonomously maps out the required workspace and establishes a virtual environment using the pipex utility. This pipex isolation acts as a secure boundary, keeping the agent's new Python dependencies separated to prevent local conflicts with the host system. Delegating software installation entirely to natural language makes strict runtime guardrails and preview parameters a mandatory step in the system architecture. The core vulnerability lies in equipping an autonomous agent with command line execution privileges to read unverified web text. This creates a massive attack surface for a specific vector known as an indirect prompt injection attack. Because the AI cannot distinguish safe data from a command, a hidden string of text on a seemingly benign web page can easily hijack the agent. The agent will then silently execute that unverified malicious text using the exact local system privileges you granted it. Providing an AI the eyes to see the internet simultaneously creates a direct reverse conduit for the internet to manipulate your local machine. This mandates a final architectural requirement before deployment: rigorous, out-of-process container sandboxing. The AI agent must run inside a strict containerized sandbox to completely separate its operational workspace from the host OS files and neutralize execution threats. Agent Reach provides a highly effective, zero-cost methodology for giving local AI direct web access. But deploying it without absolute container isolation transforms a localized capability layer into a massive local vulnerability.